So hello, today I'm going to give you a quick tutorial on how to use Microsoft Excel to make graphs, everything you need for this class. I'm going to be going and talking about some particular data that isn't necessarily data you will be using, but just the general idea. But how to do everything in Excel for a set of data. If you're using Excel, this is for the Excel desktop version. If you're using Excel online, that'll be a separate video that I'll make next. And if you're using Google Sheets, go to that video. This is just for if you have the desktop version of Excel. Now, in general, graphing, our goal is a way to analyze data. Most of the labs do require graphs. They must be made in Excel or Google Sheets or another computer program. I do not accept hand-done graphs. And this will show you how to get all of the max number of points you can possibly need to get. So all graphs need to have all the information there that you can figure it out by reading them nice and simple. Everything labeled, everything clear. And I will always say to graph something versus something else, but it will always be Y versus X. Whenever I tell you to graph stuff, I will always give you the Y first, then the X. In today's example, I'm going to graph M versus X. That means M goes on the Y axis, which is the up and down, and X goes on the X axis, which kind of makes life easy when X is X, but that'll be the horizontal. And so, yeah, Y axis vertical, X axis horizontal. And if I say M versus X, M is Y, X is X. Now, what the first thing you should always do is, take the data. And let's say you take the data, you collect this data. Well, here we go. I've gone and collected the data. What you're going to need to do is enter this into Excel. Whatever is on your X-axis, put that first, then put whatever's on your Y. So in this case, since we're graphing M versus X, what I'm going to do is I'm going to put M in column A, X in column A, X in the first one, and M in column B, as that's the second one. And then what I'm going to want to do is make a graph. So how you do that in Excel is start by selecting all of your data. And it's of note, if you put this in different corners or look different, like here it's a hand, here it's a little black X. You want to put the cursor in the middle, so it's a white cross. Select all your data. Then at the top, go to Insert. After insert, you want to make a scatter plot. So in this area, it's the one with a bunch of dots right here. Go down, select scatter, and there you go. There's your graph. Now this graph is not labeled, which is something we need to do. To label the graph, what we're going to do is we're going to go to Quick Layout and go to the bottom right one that has this f of x on it, Layout 9. When I click this one with f of x on it, what's going to happen is it'll show up a spot to put our titles, but also an equation. Where these titles are, we'll just go and type it in. Now, in this case, on X, we had X. So I'll just put that. I could also write is, I'm just going to tell you now, X means distance. So I could write distance, parentheses, X, M. That works also. And Y was mass in kilograms. So I'll just put M, parentheses, kg. Or I could also write, if I so wanted, mass parentheses kg. Either one works. So I've noted if you use this value, the quick layout I said, you'll get right here, you'll get the slope of the line. We get the equation for the line. Y equals 0.9823x plus 0.0009. That means the slope of this graph is 0.9823, which we'll come back to. Now see, the equation for any straight line is y equals mx plus b. And here we have y equals 0.9823x plus 0.0009. We're going to always ignore the y-intercept, that 0.009 in this case. We're just going to say y is slope times x. And in this case, since we're graphing m versus x, that means m is the slope times x. That mass is the slope times distance, which means we know the slope is 0.9823. And it's of note it has units. In this case, it would be kilograms per meter, because the units of slope will always be the units on y divided by the units on x. And that's everything we need in a graph. Axis labeled, trend line, and an equation right on it. You make sure you have both axis labeled, trend line, and equation on it to get full points. Now from physics, you usually get an equation. For example, there's an equation that m equals k over g times x. What we're usually going to do with this slope is we're going to compare the slope here with the value with an equation given. For example, today we're saying m is slope times x, but m is also k over g times x. What that means, putting these together, is slope is k over g. Now, there'll always be an equation like that on a lab with a graph. Don't use that equation to find the slope. Make the graph to find the slope. It's just what we're going to do is we're going to use that equation to solve for something. Like I could solve for k, because if slope is k over g, if I multiply both sides by g, k is slope times g. So we can solve for k, include units and all that. Now, if you're in physical science, you're good there. But if you're in my physics class, you need to find the slope and the uncertainty in slope. And so if you're in physics, well, if you're in physical science, just stop listening now. But if you're in physics, we can work out how to find the uncertainty in slope. Oh, I'm going to go back to this. How we're going to find the uncertainty slope is we're going to use something called the LINEST function. What you do is you select an empty cell and types equals LINEST, open parenthesis, and it kind of gives you a guide here. Known y's, known x's, constant stats. We're going to do it by selecting our y values. You just click and drag over all the y values. Hit comma. The known x's, we're going to click and drag over all your x values. And this part's kind of weird. That const thing, we're going to not put anything there. So just hit comma twice. And then type the word true. Once you do, you'll close parenthesis and press enter. If you don't remember that whole equation, it's in the notes. It's also written on the side of the room in the lab. What's going to happen is a whole bunch of cells pop up, but we really only care about two of these. The upper left one, that should always be the slope. And so this upper left, yeah, that's what we need. We already found the slope on the graph, so we should already have the slope, because make sure it's the same here as in the other spot. But what we wanted was the uncertainty in slope, and that'll be the number right beneath that. That the number directly beneath is the uncertainty in slope. Our uncertainty in slope here is 0.0059696. The rest of these numbers, honestly, you'll never need them. They can go away. And we'll just only look at those top two. Oops, wrong box. Now, what that means, sorry, you can get me video with all the bugs. What that means is that the slope is 0.982 plus or minus 0.005969, because that was the number I had here, 0.005969. On this version, I've only showed the top 4 cells because I don't need the later ones. That means the slope is anywhere between 0.9761 and 0.9879, because that's the wiggle room, that's the uncertainty. Keep in mind, uncertainty also does have units. When you put the uncertainty on the lab, make sure you include its units. The units of the uncertainty and slope will always be the same as the units of the slope. But normally you're not going to bother finding the range for the slope. You're going to we don't care about the slope. We want, in this case, we're going to solve for k. What we're going to do is you'll find the uncertainty for k and plug in as needed. And you'll go and solve for the uncertainty, whatever you're looking for, using the equation given to you in the lecture. Hopefully this helps, but that's how you make a graph. Any questions, please just come see me. Bye.